Hi, I'm Xiangnan from Singapore Geophysical Project, and currently I'm a research engineer in our team, and I am working with Prof. Elita in CCS project. It is the carbon capture and storage project, and I hope my video can give you a good understanding of what we have been doing in this project in Singapore. Thank you.
Hi, welcome to our online workshop. I'm Xiangnan from Singapore Geophysics Project team. I will be very happy to give you an introduction to carbon capture and sequestration feasibility study in Singapore. As a small low-lying island city-state, Singapore is especially vulnerable to the effects to the climate change. Some adverse impacts like rising sea levels, changes to the rainfall patterns, and increasing temperature will not only affect Singapore citizen health, but also will have an adverse impact on Singapore water supply, biodiversity, and coastlines. Reviewing recorded temperature profile is one way for you to have a straightforward view of what a terrible global temperature situation we have, and especially in Singapore. The figure in the right-hand side is the temperature profile provided by Meteorological Service Singapore. The blue line indicates the global temperature. You can see it has been increasing since 1950, and there is no doubt that it will still increase in our century, whereas the red line indicates the temperature of Singapore, which has a bigger jump than the global one. Singapore made a very strong commitment on the Paris Agreement, and the Singapore government intends to meet those commitments. Singapore has promised to cut its emissions intensity by 36% from 2005 levels by 2030. In 2005, it created the equivalent of about 0.176 kg of carbon dioxide for each GDP dollars. It aims to lower this to 0.113 kg per dollar by 2030. A reduction of about 36%. Although Singapore is small, and what we save in carbon emission may have negligible effects worldwide, we are still trying to do our part in fulfilling the Paris Agreement, and what we develop here can be applied not only in Southeast Asia, but also can be applied worldwide. If the data is not that impressive, I believe that this picture in the left-hand side will impress you. Look at the road covered by rainfall during the rainy season. You can imagine what will Singapore be if the mean sea level had a 1 meter increase in the next century. And it can be true. Look at the figure in the right-hand side. This is a model prediction by IPCC, also known as Intergovernmental Panel on Climate Change. In this model, it predicted that the mean sea level of Singapore will rise 0.8 meter by the end of this century. So it is time to take actions. As a small tropical city in Equator, Singapore has already realized that the climate change will have a huge impact on them. According to Singapore emission report, Singapore only emitted 50.9 megatons of CO2 in 2014. Comparing with other giant emission countries like United States and China, Singapore only contributes a very small fraction of global emissions, and the most significant contributors for Singapore CO2 emissions are industrial sectors and power plants. Someone may ask, why doesn't Singapore choose renewable energy like hydraulic or PV solars? The answer for this question is that given Singapore a small size and dense urban landscape, there are challenges to use alternative energy sources such as solar PV and hydraulic. But we can sequestrate greenhouse gases into the subsurface. This technology is called CCS. So where can we collect CO2? In another word, where is the CO2 source for our project? The answer is definitely the Jurong Island, which is located in the western part of Singapore. Jurong Island is the heart of Singapore chemical and energy industry, acting as the operational base for leading petroleum and petrochemical companies. And also, there are many power plants there. As you can see in this picture, it is an actual potential CO2 capture option being considered for Singapore. You can imagine what an emission giant the Jurong Island is. Frankly speaking, every night from my hostel, I can see the flare and emission from Jurong Island. Although Jurong Island has fairly thriving chemical and energy sectors, which contributes to 1.8% of Singapore's gross domestic product and employing more than 25,000 workers, but also it is the biggest emission contributor among Singapore, which our project will focus on. The Senior Minister and Coordinating Minister for Singapore National Security, Teo Chen Hin, had shown Singapore's willingness to carry out CCS project. He said, "We are also working with industry and our research community to study a new technology such as carbon capture, utilization and storage, and low carbon hydrogen to evaluate and plan the next steps for Singapore." The whole process of a CCS project concludes 4 steps. Firstly, we shall collect CO2 from CO2 sources. The source can be a power plant and the industrial sector. In this cartoon, it is very interesting that the industrial sector is a carbon drink factory, and then do the dewatering and compressing process with CO2 to make it become supercritical phase. Secondly, we will transport CO2 to a suitable site via pipelines or the tanks. Thirdly, we will inject CO2 for enhanced oil and gas recovery or into solar aquifers. Finally, we will monitor subsurface situation for permanent sequestration. After collecting CO2, we move to the second part. There are 5 choices for us to store greenhouse gases, but our project will focus on the depleted oil and gas reservoirs and solar aquifers, because for the depleted oil and gas reservoirs, there are available information from petroleum industry. We can get accurate data and use a reliable storage capacity for our sequestration project. As for the solar aquifers, it has shown a huge potential to store CO2 in solar aquifers, but it should notice that when considering solar aquifers, we should do a survey of total dissolved solids, because in some countries the solar aquifers can be drinkable. We cannot contaminate drinkable waters. As for the enhanced oil and gas recovery, together with coal-bed methane, there will be alternatives. Because when you sequestrate greenhouse gases into subsurface by these 2 methods, you are still get oil and gas production off, which will still increase carbon footprint, especially for coal-bed methane. It is even a worse greenhouse gas than CO2. And there is another potential method for us to sequestrate CO2. It is CCS combined with geothermal grading energy. A combination CCS and geothermal technology can decrease costs by sharing injection wells. Besides this, using CO2 as heat transfer fluid would reduce the water consumption and saving pump cost. The general workflow for our project can be concluded as several steps. Firstly, we shall identify the suitable sedimentary basins for Singapore. For example, from their neighborhood like Sumatra Basin in Indonesia and Tapis Basin in Malaysia. And then we will require data from available wells and seismic data to have a better view of our target basin. For example, we need the net porous interval thickness, porosity, permeability, and geothermal gradients. We have enough data and the data is reliable and accurate. We would use deterministic method to determine the capacity of target basins. But if we do not have access to accurate and reliable data, we can use probabilistic method to deduce the capacity for target basins. Several criteria would be taken into consideration while ranking the sedimentary basins. For example, we will consider the distance between Singapore to target basin, and its capacity of sequestration of CO2 will also be considered. Our final product can be a resource reverse pyramid for CO2 capacity. Theoretical capacity is based on the physical limitations. For example, the pore space when all CO2 fills in rock pores, or the volume of CO2 when it dissolved in maximum saturation. This is an unrealistic number because normally there are many constraints. Effective capacity is taking geological and engineering issues into consideration, while the practical capacity is based on technical, legal, regulatory, infrastructure, and general economic barriers. The matched capacity is obtained by detailed matching of large stationary CO2 source with geological storage sets that are suitable in terms of capacity, injectivity, and supply rate. Thank you for your attention. I hope my video is helpful to you. This is a member-directed research project by ExxonMobil through Singapore Energy Center. If you want to know us more, please visit our official website.